let's just move on further and talk about the third algebraic method with the help of which we will solve the pair of linear equation, and that method is called as nothing but the cross multiplication method. So in the cross multiplication method, we will also use the pair of linear equation altogether in order to get the value of x and y. So for an instance, if we are talking about the pair of linear equation as a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So in the cross multiplication method, when we will solve these pair of linear equation together, then we will get the value of x and y as x is b1c2 minus of b2c1 by a1b2 minus a2b1, and we will get the value of y as c1a2 minus c2a1 by a1b2 minus of a2b1. So these are the two values of x and y which we will get after solving these two pair of linear equation under cross multiplication method. So now we will discuss how we will get the value of x and y in such formation. So let's just talk about how the value x is b1c2 minus b2c1 by a1b2 minus a2b1, and how the value of y is of this form. So let's just talk about solving these two pair of linear equation. Now let us suppose if we are talking about these two equations, so let us suppose I'm taking these two equations as the equation number 1 and 2. So for an instance, if we have the equation this as 1, the equation this as 2, so the step number 1 we will take using the elimination method. We all do know that in the elimination method, in order to solve the two pair of or the pair of linear equation, we just wanted to make the coefficient of either x variable or either y variable same. So in the same manner, we are using the elimination method over here. So we are saying the step number 1 is multiply 1 by b2 and 2 by b1. Means we have to multiply the equation number 1 by b2 and 2 by b1, because we are making the coefficient of y similar. As we can see over here, the coefficient of y over here is nothing but b1, the coefficient of y over here is nothing but b2. So if we'll multiply this by b2 and we'll multiply this by b1, so it would be of the form b1 b2y, b1 b2y. So both of the coefficients of the variable y would be same. So let's just multiply both of these equations by b1 and b2. So we'll get the values as b2 a1x plus b2 b1y plus b2 c1 is equal to 0, and the second equation is of the form b1 a2x plus b1 b2y plus b1 c2 is equal to 0. Now let's just call these two equations as the equation number 3 and 4. Now you can see over here, as you can see over here, in these two equations we have the coefficient of y as b1 b2, we have the coefficient of y as b1 b2. If we'll subtract both of these equations, then these values will get cancelled out with each other and we will get the value of x over here. Now let's just move on further toward the step number 2, in which we will subtract these two equations. So note down these two equations as we are moving toward the step number 2. Now if we are talking about the step number 2, so step number 2 says subtract the equation 4 from 3. So we'll get the value of x as b2c1 minus b1c2 by a1b2 minus a2b1, with the condition that denominator cannot be is equal to 0. The denominator, that is b2a1 minus a2b1, cannot be is equal to 0. So let us suppose I'm calling this equation as nothing but equation number 5. Now this is the value of x. So we again just wanted to find out the value of y. So the step number 3 would be of the form substitute the value of x either in the equation number 1 or either in the equation number 2 in order to get the value of y. So if I'll substitute x as b2c1 minus b1c2 by a1b2 minus a2b1 in any of the two equations, that is equation number 1 or 2, we'll get the value of y as nothing but c1a2 minus c2a1 by a1b2 minus a2b1, again with the same condition that denominator cannot be is equal to 0. So let us suppose I am further taking the step number 4. The step number 4 is calculate a1b2 minus a2b1. So now till the step number 3, we are clear about how we have calculated the value of x and y in the very first introductory part of the cross multiplication method. So this is our x and this is our y. under the cross multiplication method, as we have solved the two linear equation, or we have solved a pair of linear equation. After solving both of them, we are getting the value of x and y as these under the cross multiplication method. Now we are further talking about some other important things that we have to calculate before actually calculating the value of x and y. So what are these? So the step number 4 actually says that we have to calculate a1 b2 minus a2 b1, that is the denominator of x and y. As you can see, the denominator of x is a1 b2 minus a2 b1, the denominator of y is a1 b2 minus a2 b1. So the step number 4 actually says that you have to calculate a1 b2 minus a2 b1 first. So further it says, step number 5, if a1 b2 minus a2 b1 is non-zero, or we can say that if a1 by a2 is not is equal to b1 by b2 ratio. As we do know about this ratio, we have already done it when we were doing the graphical formation or representation of the pair of the linear equation, that whenever a1 by a2 is not is equal to b1 by b2, then we have the two lines as intersecting. Those are the intersecting one which intersects each other at a particular point, and they will provide us a unique solution. So always remember, whenever we have a1 b2 minus a2 b1 non-zero, or we can say if we have a1 by a2 not is equal to b1 by b2, then the solution that we will get is nothing but a definite solution. Now let's just further talk about when we have the other conditions. So the step number 6 is nothing if a1 b2 minus a2 b1 is equal to 0. If it is equal to 0, it means that a1 by a2 is equal to b1 by b2. Then for such a condition, two possibilities are there. So the very first possibility is when all the ratios are same, it means it has infinitely many solutions. And if we have the condition that a1 by a2 is equal to b1 by b2, which is not is equal to c1 by c2, then we have no solution. As we know that this formation is actually means the two lines are actually coincident, and for such a condition we do know that the algebraic interpretation says that the two lines are actually parallel to each other. So for such a condition, two lines are parallel, and for such a condition, two lines are coincident. It means that if we are using the cross multiplication method, then for the step number 5 only, when a1 b2 minus a2 b1 is non-zero, we have to calculate the value of x and y. And if we are talking about the step number 6, if we have the denominator, that is a1 b2 minus a2 b1 is equal to 0, then we do not use the cross multiplication method at all in order to find the value of x and y. So we'll generally says that if the ratio is similar, then we can say it has infinitely many solutions. We cannot solve it further. And again, if this formation would come out, we can say there is no solution at all, and we will not solve the value of x and y. So let's just talk about all these steps furthermore. So these are the 6 steps which are actually related with the cross multiplication method. I hope all these steps are clear to you. Now let's just move on further and let's just talk about a shortcut method. What is a shortcut method? So for the two equation, or we can say for a pair of linear equation, that is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, instead of remembering the value of x and y in case of a cross multiplication method, we can calculate it in a shortcut way. For an instance, let's just start calculating it. First of all, we have to write the variable x, y and 1. So let's just see over here. The shortcut method says that for any pair of linear equation, first of all we'll write x, y and 1. X, y are the variables that are present over here. So we have taken x variable, y variable, and further we have taken 1. Furthermore, again, we have the coefficients of the x, y as a1, a2, b1, b2 and the constants as c1, c2. Now we'll write all these coefficients in a particular manner. Let's just see how we can write. B1, B2, C1, C2. So we'll start with the coefficients of y variables. We'll start with the coefficients of y variables. It is B1, B2. So we are writing B1, B2 over here. Again, we'll write the constant terms. So we'll start with this. So let us suppose I'm calling this as 2. Let us suppose I'm taking this as 1. I'm taking this as 2. I'm taking this as 3. So we are writing the coefficients of 2 first, means the y variable first. So this is 2. Again, we are writing the constants, that is C1, C2. So we are calling it as 3. Again, we are taking the coefficients of x variable as A1, A2. The coefficients of x variable is A1, A2. So this is A1, A2. Again, we are taking the coefficients of y, that is B1, B2. So it means we are moving in a cycle. We are starting from the coefficients of the y variable and we are ending with the coefficient of y variable. So we can also remember it using the concept as, 2. Let us suppose I'm writing it over here. 2, 3, 2, 3, 1, 2. 2, 3, 1, 2. So using this particular method, you can also remember that from which coefficients we have to start this process. So first of all, we have to take the coefficients of 2 first, the numbers or the coefficients that are present in the second place, and then we have to take the terms that are present at the third position, that is C1, C2. Then we have to take the coefficients of x, that is A1, A2, that is on the first place. Again, we have to take the coefficients of y variable, that is on the second place. So 2, 3, 1, 2. Now we have to multiply these terms in a very specific manner, in a cross multiplication method. How it is? As you can see, first of all, we have to multiply B1, C2. Always remember, we have to start with the very first term and we have to go in a cross method. So B1, C2 will get multiplied with each other, and then a sign of negative comes in between. And then we will multiply B2 with C1. Then we will multiply B2 with C1 in this manner. So always remember, whenever we are multiplying these two terms, a sign of negative would come in between. Means B1 C2 minus B2 C1. In the same way, we'll start the procedure with C1 again. So C1 will get multiplied with A2. So it is C1 A2 minus C2A1. Again the same process. A1 will get multiplied with B2. So A1 B2 minus of again A2 B1. And we have to write all these terms in the denominator of x, y and 1. How? Let's just see. Very first term, x by A1 B2 minus A2 B1. We are talking about this term first. How? Let's just see. As we can see, we have the x as x by B1 C2 minus B2 C1. You can see the value that we have calculated after multiplying all these terms, that is B1 C2 minus B2 C1, is actually in the denominator of x variable. In the same way, the value C1 A2 minus of C2 A1 would comes as a denominator of the y variable as y by C1 A2 minus C2 A1. Similarly, A1 B2 minus A2 B1 would come as a denominator of 1. So it would be of the form 1 by A1 B2 minus A2 B1, and then we have to take them as equal to each other. So as you can see, we have taken x by the term this is equal to this term, and further we have to take them all equal to each other. So let us suppose if we have to find out the value of x, then we are taking this p by q formation equivalent to this formation. So if we'll make them equal, so the value of x would be x by b1 c2 minus b2 c1 is equal to 1 by a1 b2 minus of a2 b1. So let's just take this term towards the other side. So x would be b1 c2 minus b2 c1 by a1 b2 minus a2 b1. This is nothing but the value of x. Similarly, in the same way, we have to take this p by q formation of y equivalent to this. So if we'll take y is equal to this, then we'll get the value of y as c1 a2 minus a2 a1 of we have taken c1 a2 minus c2 of a1. So this is c2 of a1 divided by nothing but a1 b2 minus a2 b1. This is nothing but the value of y. So instead of remembering this p by q formation, you can use this 2-3-1-2 shortcut method to find the value of x and to find the value of y under the cross multiplication method. I hope the shortcut method related with the cross multiplication method is all clear to you.